Anvilos is still collecting data. But first things first, actually, I'm going to go ahead and jump to there. Actually, let's just do this. How do you think we would describe this data here? Like if we were to continue to do this infinitely many times. Serena, what are you thinking?
Wait, what's the word? It starts with D or C. D, you know what I'm talking about?
Sanaa's not here.
She is not.
Did you even have?
No, wait. Why can't I think of it?
Distributional.
No.
What's the word?
So
It's like when there's spaces in between them and it's not continuous. It's the opposite continuous.
Did I
gaps? Discrete?
Discrete.
Okay, so one, I will say this. It has to be discrete because it's 1, 2, 3, 4, 5 rolls. Like we can't have anything in between. I was not thinking along those lines, but yes. Now it's discrete data. It's not a discrete distribution. Okay, so keep that in mind. So discrete, quantitative, number rolled on the die. Actually, this would almost be categorical because it's not measured or counted. I don't know. I'll think on that. I guess you count the. Don't worry about it. What I want to point out is, what I'm asking is, if you were to continue this forever, what do you think that graph would look like?
It's just all equal.
Huh?
It's like all equal.
You think it would end up being about equal? Why is that?
Because there's an equal chance of landing on each side.
So, clearly we had a little bit of a bias towards 5. Not sure how that happened, but yeah, we see.
I think that was my fault.
Well,
How?
also,
I think
wouldn't
that
it
was
be
also
like
I
weighted?
had
weighted.
like 4 or 5.
It's not fair.
Function dice, so like weighted almost.
They're not supposed to
the
be.
same. I had like a lot of
This
ones.
won't
that
let me
Yeah.
pull out the, you know what I'm looking for.
Yeah.
We did this in Algebra 2. That's not supposed to
I think it's
happen.
on the right one.
Yeah, I think so too.
Oh, that's 2. Well, that's just a mess.
Okay? Hey, don't come at me.
Yeah.
Got it?
What did I do if you're talking
You can't get it
You
worse than
sound like a
Serena.
snake.
There we
I think
go.
you get worse than Sonata.
There we go. Alright, so what happens long term when you roll a die? It becomes what?
Unify.
Say it again. Uniform! Oh, there's that distribution, right? So, long term, when we continue to roll a single die, I think Peter said earlier, someone else may have said it as well, they have what likelihood of being rolled? The same, right? An equal chance of being rolled. And so because of that, we get a uniform distribution, right?
Is that
Okay.
on my desk?
Say again.
You just like bumping his legs all around.
Alright, so we get a uniform distribution when we do lots and lots of them. And the more you do, the more uniform it looks.
Ours was prettier.
Okay?
Yeah.
Penny throw. Now, y'all's penny throw was significantly better. What type of distribution did we get for the penny throw? Skewed right. Why is it skewed right, by the way?
Because
You can only go so close to it.
I will say this, do you know a way that we could have changed the way we did this and it would have been closer to normal?
Could have had like a set
like a
off,
maximum.
like you can't get out this way.
Like
Oh, I think you're measuring.
Negative.
You're measuring from the wrong blue line. You're supposed to measure from that blue line, not that one.
What?
Oh, I thought
Oh,
it
you're supposed to, you were getting like right on top, yeah, it's supposed to be like,
I thought we were supposed to try to throw it to that way.
yeah, uh-huh.
And then you
And-
measure from that line.
And you measure how far you got away from that line. What did you do?
I was like, yeah, that.
Right, what'd you do?
Okay.
Well, you measuring how
So
far
how about you
can
just
get?
find out how far it is to that blue line, subtract that out each time, but it's fine. Here's my question though, okay? What I was actually gonna point out is, it didn't matter which side of the line you went to, you counted it as positive distance, right? Because you did distance, not displacement. For those of y'all taking pre-calculus or calculus,
Please don't remind
you
me.
talked about
Do not
displacement,
remind
so
me.
whether it goes beyond or stays near makes a difference.
You slide
But
out.
it's fine. We'll just jack them upward. It's all good. But in this case, we got a mound around the 0, right? Like we got really between the 0 and 4 feet. And then there's a little bit maybe of potential outliers out to the side, right? So skewed right. And then we did the stopwatch over here. Okay. And so with this stopwatch, we have a couple of 4.5s, but let's just pretend like those don't exist.
How do you forget that?
What kind of distribution are we looking at if we kind of ignore these right here?
I mean,
Skewed right still.
Normal.
Roughly, yeah.
it's pretty usable.
No.
So remember, if I ignore these, I'm kind of looking at it like this, maybe-ish. So it's not perfect, maybe, it's not a true drop in here, maybe a drop, and so we get 2 peaks. But what do you think it looks like if we do infinitely many of these?
It'll start to center, like, unimodal.
It'll be more unimodal, it'll be centered right around what data value?
Around 4.
Around 5? Because remember, what were we trying to get it to? 5, right? And if like you're being intentional about trying to get that 5, get closer and closer, then you'll get you'll get something closer to that 5. So when we look at, where's the projector remote? Did I hide it over here when I came in? Yeah, I did. Okay, so, oh yeah, we're gonna come back actually to that. So, go ahead and get the AP free response that I recommended you do over the weekend. Now, we're gonna talk about it in just a second.
I thought you told us to wait for class.
Yes, you did.
Yeah, I thought I said I recommended
No, I
it now.
thought you said to wait
You did not
because
say all
you said
that.
that we do it in class.
You don't in class.
The free response that we do.
Did you do the math?
You
We were too busy writing our papers.
Yeah, I thought I told y'all. I thought I told y'all to do this
I think
one.
you're just behind.
No?
Oh no, I was writing my thing.
Okay, how about this then? It's okay if you didn't do this one.
Damn it.
We're gonna talk, let's just talk through this one, just kind of set you up to do one in a minute. And we're gonna come back to these distributions a little bit later. Okay, so first off, make sure you really focus on, so this is a 2010 Form B1, number 1. Okay, it has 3 box plots. You did not get this one last week. I'm gonna have to find it for you probably later.
I actually brought my own hot chocolate and just used your hot water.
You brought your own hot chocolate? Why don't you want to share it?
I only brought one packet and I'm not sharing one.
It's just not cold enough for it.
Right here.
Here you go. I knew I had one copy for you. Alright, so,
You said
So you're not.
right here, okay? So, right away, when you look at this graph, we need to make sure we read context. When I first looked at this one, I felt overwhelmed because I just didn't read the context. But what we have are 3 rivers, and they've been contaminated with pesticides because they were located near an abandoned pesticide dump. And so they measured the concentration of aldrin, a commonly used pesticide, and they measured how much aldrin was in these 3 rivers. So now we're looking at these rivers. What is something more than likely that the APA exam is going to ask at this point?
What's the center? Or what?
Just the center?
No.
Cuss.
They're gonna ask us to cuss,
Cuss.
right? Cuss it in context. More than likely, because there's more than one here, they're gonna ask us to compare the distributions. So make sure we pay attention to that. Notice, what does they say? Compare the distributions. Now, I need you to remember, Nate, when we say compare the distributions, what all are we looking at? Center, unusual aspects, shape, spread. There's something you're missing.
Skew.
In context. Center, unusual aspect, shape, spread, in context, and because we're comparing, we've got to be
Explicit.
explicit was the term. Discrete means like sneakily. We're not trying to be discrete. We're trying to be clear. We want to say this is what it is. We need to use that comparative language. Okay, so when I look at these 3 rivers, let's start with center. How would I describe the center here?
Of which one?
We're comparing them.
Oh. River X is the highest median.
So River X has the highest median.
Followed by River Y. Oh wait, do I have to say the number?
Do you have to say the number?
They don't give it to you exactly, do they?
I
I don't give it to you exactly.
Would it make sense to do the step plot first?
River X
What
also
mean?
has the largest
Not really. I'll talk about the why. Say again.
River X also has the largest range.
So River X has the largest median and largest range. Okay.
And largest interquartile range.
And
The largest
mean.
IQR. So I want to say this, we are saying largest, things like that, but let's do this, and so I'm glad I'm going to bring this up. When I am writing about this, if you're going to talk about median and compare them all. River X has the largest median. Now median what, guys?
Median concentration.
Concentration of Aldrin, right? So River X has the largest or highest median concentration of Aldrin, then River Y, and River Z has the least. I've talked about my center. I've compared them explicitly. Now, can you give approximations? 100%. So you could say River X has the largest median concentration of Aldrin, maybe put parentheses, approximately 5.2. More than likely, because it's not exact, you don't have to do that though. We'll see the rubric in a second. All right, so I've got center. What goes really well with measures of center? Measures of spread. You can do, really you can do any of them. I always just like to put center and spread together. That's just me. So
Let's do maximum minimum.
River X has, or who has the largest spread?
River X.
River X, then
River Y.
River Y, and then River Z has the least, right? So being explicit with that. Now, I will say this, does it change whether you talk about range or IQR?
No.
So I would just pick one of them. River X has the largest IQR, then River Y, then River Z has the smallest spread in its IQR. Does anyone know why I did go with IQR and not range though?
It's easier to tell the IQR with the lines in the box plot. Because it shows you the IQR.
It does. You can easily see the IQR, but is that easier than what the range is to look at?
Well,
I mean, it's
the
the
range
same.
could have outliers that we can't see because of the way that the box plot is.
So, I mean, if there are true outliers, there might be dots out there, but I will say this, so you're getting closer to it. What is an IQR in, whereas a standard deviation and the range are not?
It's,
Based on median.
it's not resistant.
So, which one is?
Resistant.
Yeah, the IQR related to the median is resistant, whereas the range and the standard deviation are not. So I'd probably go IQR personally. Doesn't actually change anything though, but notice again I've talked about spread, I've been explicit with my comparisons, I've used context. I will say this, notice I use context really heavily in the measures of center, right? So do I need to continue talking about the context every single time within part A? No, as long as you do it once within each part, you're good. Okay? Shape. How would I describe?
River X is skewed right.
So River X concentrations of Aldrin is skewed right. While we don't have to, but I'm doing it anyways. While River Y is
Pretty symmetrical.
roughly symmetrical. Notice we do say roughly typically in statistics. And River Z is skewed left.
And a marker. Mr. Mark.
Do you have a multi?
What about unusual aspects?
It looks like River X may have an outlier because it's being skewed so far. Maybe, I don't know.
What do y'all think? Could River X have an outlier?
They could all have outliers.
Well, no, because there's not, wouldn't there be a dot if there was no outlier?
So typically, now you can do a box plot without a dot, and it wouldn't have an but we don't see a dot. But I'll say this, I can look at this and know, no shot at having an outlier. Do you know why?
1.5
Oh,
times.
Because of the
The
concentration of the
IQR so
bottom.
large.
Yeah, so notice that IQR is what, 3? 1.5 times 3 is 4.5. 4.5 past 7.5 is like 12. We don't have anything out there. So notice, yes, it is skewed to the right. However, we have such a large IQR, it's not, there's no outliers. But good thing, but yeah, just say potentially, but again, we should be able to recognize here that IQR is way too large to have outliers.
So do you have to put unusual aspects on every single one?
No, you just say, hey, there's no unusual aspects.
Oh my god.
So I assume in this case there are none.
Correct. All right, let's see what the rubric said. Oh no, there we go. So comparing the medians reveals the concentration of Aldrin tends to be highest for River X and lowest for River Z. Notice they only compared 2 of them, but with saying that River X is the highest and River Z is the lowest, what does that imply about Y?
It's in the middle.
It's in the middle. the AP exam's weird about some small details. Other exams, they may not have counted that as being enough. So just do all three, just to be safe. Okay, about 50% of the concentrations of aldrin for rivers X and Y are higher than all of the concentrations for river Z. Well, that seems unnecessary. We'll see in the rubric in a second. Remember, these are just idealized answers. River X also displays the most variability, as seen by the largest range and largest IQR. River Z has the least by range and IQR. The shapes differ in that, yeah, that's it. So let's see what they said. Essentially correct if you have context, center, spread, and shape. Notice they didn't include unusual aspects. Any idea why?
Because there are none.
Because there weren't any, so you didn't really need to. But again, there's been some exams where they expected you to acknowledge that there were none. So just go ahead and talk about it just to be safe.
Isn't this from 2010 anyway?
Oh yeah, that's
Give
a
a marker.
long while ago.
Listen, it wasn't that long ago, okay? It was only a year after
was.
with
Oh.
I took the
Yeah,
AP exam.
Oh!
I know!
It was a long
You
Yeah.
took
while.
2009?
I graduated high school in 2009.
Oh.
That's a long
I know you're
time.
all like 3 years old, but that's
We were
not-
1 years old.
Oh my god!
Yeah.
I was like,
Well, I would
I was
have, I
Okay.
would have been two.
Getting back to statistics.
Yeah, I would be.
I was less
I
than
would have
1
been
year
2
old.
years old.
Oh.
Like,
So,
I would be
Sophomore?
like,
Oh yeah, Peter would have been like 6 months old.
Peter would have been like unborn.
I was a kid.
so statistics, okay.
Times that.
And you had to make a comparative statement involving all three distributions for at least one characteristic. Notice specific numerical values are not required because you couldn't really have specific numerical values, right? Just directly, explicitly comparing them. That's it. Questions about this one? About part A?
Nah.
Okay. So part B, oh yeah, that's just partially correct. All right, no, I don't want to go there yet. So part B says construct a stem plot that displays the concentration of aldrin for river X. So I'm glad Nate talked to me because he made a fantastic mistake that I hadn't even thought to talk about, but I'm so glad he showed me what he's doing so that we can all learn from this. B, I know you're going to snicker like, blah, blah, blah. No, make all the mistakes, they're great. So it says construct a stem plot that displays the concentrations of aldrin. So one, make sure you use your tools, right? Title, units, label, scales. But what I want to focus on here is this. What's the lowest value? Was it 3.4? Okay. So this is what Nate was doing.
Oh, simple. Let's go.
So Nate, what were you thinking you had to do here?
I thought I had a decimal.
You thought you had to add the decimals. Do you have to add that decimal with the stem plot? How do we? How,
Use key.
you just use the key. Make sure that you don't. What all needs to go on the right side of that stem plot?
Only
Just the last number,
And do the.
right? So remember, the stem is everything else. The plot is just that single last number, and you would just use your key. So 3, 4.
That's just it.
It's 3.4. Is it parts per million
Yeah.
of aldrin or whatever? Okay. Yes, ma'am.
So what if like number is like 3.45?
Good question. One, I would never make a sim plot for that. Okay. Two, if they did that kind of awfulness to you, you would do 3.4 and 5. Yeah. Because you only put one digit on the right side of that stem plot.
It should be
So
like
we have to do
34.
that for every single, like, what if you... What about the only one that did 4.4, which is like 4.0, and then the 5 on the other side, just like have to do points all the way down? Like that?
So like 3.4, 3.5, 3.6.
I'm saying, like, what if like that was the only one that was in hundreds, and all the other ones were in tens?
Oh yeah, then I would never do it that way.
Okay, so it's just
Yeah,
it's just a
like,
bad- it's just a
so
bad-
here's the thing to remember. How often do I recommend you make a stem plot for the real world?
basically.
Basically never, right? That's an AP thing, okay? So you have to know how to make an stem plot for the AP exam, but they're not the best. What are the two better distributions? Histogram is the distribution for me with quantitative, and then a dot plot. Mosaic plots are great for categorical when there's two variables, two categorical variables. All right. So there's our stem plot. And I'm gonna go ahead and show you what the sim plot looks like. This is gonna help us with C. Describe a characteristic of the distribution of aldrin concentration in river X that can be seen in the sim plot but not in the box plot. So let's see. What do you see in that stem plot right here that's not in the box plot? A gap, right? Can you ever see gaps like that or bimodal in a box plot? What's the only thing that box plots can show?
IQR, range.
The IQR, the range, but also the skewness, right? Or symmetry. They can't even show if it's unimodal or bimodal. It can only show the shape, the skewness, okay? So part C, that gap is not apparent in the box plot. Oh, I screwed that up this one. So essentially correct if a reasonable stem plot that includes a leaf unit key is provided. It's not necessary for the key to include measurement units, okay? Here's the thing, just add that extra bit just to be safe. Just make sure you're precise with it. Essentially correct if the response includes a recognition of the gap in the stem plot and gives an indication of where the gap occurs. So one thing I do want y'all to see on this, because this is the second time I've seen this recently, if you talk about a gap, you have to talk about where the gap is. Remember we saw that on the demonstrate understanding last week as well, right? So there's a gap from 5.6 to 7.3 parts per million of aldrin. So you got to make sure, talk about where that gap is. Do note you could have also just talked about it being bimodal, and if you talk about bimodal, you need to talk about where the modes are, where the two modes are. Either one would work. Typically, I go with the gap. But guess what? It's your choice. It's choose your own adventure as long as you address that difference. What's your question, Serena?
I don't know. Just
You don't like
this choose your own adventure book where you like went into a fairy world and then.
Oh my god.
Sounds like a great time. All right. So here's what I want us to do is I want us to use this 2018 number 5. We're going to do this AP free response. I'm going to again, like last time we did this in class, I'm going to give you 10 minutes.
Where's the second one?
It's not the back.
It's 13, but it's 10 minutes I'm going to give you right now, and I'm going to have you put your responses on vertical
No, it's
surfaces.
not. Oh my god.
Huh?
This is, wait, this isn't. Where's
Right.
this? We don't have that.
Yeah, we don't have it.
Yeah, that's a different one.
Dude, one of the ones I printed today. Can you throw me a marker?
Yes, here it is.
Yeah, you have it.
No, it's not that.
That's
Yeah,
it.
there's.
No,
No,
it's
it's not.
different.
It's
It's different.
It's giving us the middle finger.
It's the same one as
It's West is the same. That was high school.
Oh, I messed up and reprinted the wrong thing. Okay, let's do this then. Here, I'll just print this one out.
Brayden, can you throw me that green marker on your desk?
You free have one.
Thank you. No, this one's dry.
Like your jokes.
Oh. Got her.
I couldn't say what.
Fine.
This is a toxic work environment.
You'll survive. Also, for you to call it that, it requires you to wear this. Oh.
Fired, shots fired.
Mr. Kenny,
I wouldn't take that if I were you.
Got her.
you're just the instigator.
I don't know.
Yeah.
I just wouldn't let that
I
happen
do.
to
He's
me.
definitely an instigator.
I wouldn't let that happen.
I know because I am one as well.
We can tell.
Okay. So here's what I'm going to, while this is printing out, I'm going to establish what's going on here. So we have two different high schools, right? We've got histograms summarizing how many years that person has been teaching, okay? So teaching years recorded as an integer with first year teachers recorded as 1. Oh, you almost let me forget.
I literally just talked to you about that.
I know, but like, once I got started, okay.
What happened?
Sorry. Remember when Brayden was asking the question about the bins, right? And where when you have that last bin, if it's equal to or not. So what I realized was it does depend on how the data is collected. For example, remember in one of the demonstrated understandings how it was like a 46 question test or a quiz or something, like the economics test maybe? That sound right? Well, at that point, there's a cap of getting 46 right. So in your last bin, you would just go ahead and say less than or equal to the 46 and count 46 in the bin before it. But in this case, right, is there a chance that someone teaches more than 34 years?
Yeah.
Yeah.
Yes. So instead of doing less than or equal to with the 34, you would just make another bin here for the next group, okay? So what I'm trying to point out is if there's a maximum, then yes, you include the last one in that bin. Because like with 46 questions, you're not going to go to 47 because there's not 47 questions. But when you can always add another year in here, just do the next bin.
And have nothing in it.
So it'd be less than 34, less than or equal to 31. But yeah, this one would be 34, less than or equal to x, less than 37. So there could be another one, do that. Now, let me also clarify, I've never seen anything like that on the AP exam. I just wanted to be precise in my language when I realized that. So if you could add another bin, then go ahead and do that. But if there's a cap, then don't.
So you said they won't ask about it.
No, they will not ask that kind of splitting the hairs question. Does that help clarify that detail there? Okay, so now, we'll just take the 10 minutes, you can read, start writing. Once I get the last paper out, 10 minutes starts.
I can't read.
Sorry, I did not print
Red
this out.
has five.
Alright, 10 minutes starts
I
now.
don't even have it yet.
Too bad, work faster.
Do we write it on the paper? Do
Yes, or on the back if you want to write some there.
we write it on the desk?
Sure. Okay, I just print one printout for you as well. Yes. Yes.
I'm pressing against straws. Sounds pretty good.
By the way, if you don't have a calculator, you definitely need one. Go grab a calculator.
Yeah, I got you.
And if you were stuck on a part, make sure you just move on and we'll come back to it and talk about it. This, and I'm looking at the median teaching year. Which school had a median teaching year of 6 years?
Probably B.
Not as probably,
Definitely.
definitely.
8.
Because
Okay.
it's our step.
So median of 6 years. And I know they say probably, but it's for sure, right? Like when I look here, and this is a big reason why we looked at that skew the script lesson and we talked about this last week. How many data points are in here?
Not.
221. So if I want the median, I've got one in the middle, and how many are on either side?
Half.
Two-tenths.
That's it.
Isn't that a total of 221 right there?
Indubitably.
Indubitably, yeah, okay. So we got 79 right here, and 34 right here, and what's 79 plus 34?
Something.
Something, we got calculators, don't we?
Oh, wait, let me go.
113.
113.
Okay, so
Quick math.
111
It's not Asian.
has to be somewhere between 4 and 7, doesn't
I
it?
mean,
So that could have a median of 6. If we look over here though, this is 46, and I think this would have to be 100 and 100, right? So 46 plus 48, okay? Notice I have not gotten to 100 yet, that's only 94.
Wait.
So that would be 34. So my median has to be somewhere here between 7 and 10.
Indubitably.
Okay? So remember, it does specifically say that the upper part of the bin is not included, right? So on the histogram, each interval represents possible integer values from the left endpoint up to, but not including the right endpoint. They were intentional about that. So, median of 6 years, median of 7 years. Please note that that question of reading a histogram does show up. By the way, did they ask us to cuss this data?
No.
It's not a guarantee.
But how do you like
Stop,
justify,
you're
like how do you explain that? Like, you showed us how to do it, but like how do you like explain?
Could you just use like the
Because it says justify.
Use those words, put that into words. I'll show you what they did on the rubric in a second. But literally, like talking about the fact that the 111th data point has to fall between 4 and 7 means
Oh,
that
okay.
median could be 6 here. Whereas the 101st-ish data point would have to be between 7 and 10, so the median could be 7.
Gotcha.
What about just talk about like the shade, because like high school B has a high, it's like more right skewed than,
It is more skewed, right? So the median would have to be less.
yeah.
Yes, maybe. I don't know if they would accept that for an E. We'll see in a second. That's what I'm thinking about. But here's the thing to remember. Like, at the end of the day, a median separates the bottom 50% of data from the top 50%. So look at your refraction of the data, right? That's the whole idea of a median. Okay? B.
That's a lot of counting.
You got calculators, guys?
I did it.
It's too hard.
I did it. I did it.
Got calculators. Alright, part B though. It says an additional 18 teachers were not included with the data recorded from the 200 teachers at high school A. The mean teaching year of the 18 teachers is 2.5, was the mean teaching for all 218. Guys, a problem like this shows up on the ACT, which I guess this doesn't pertain to over half of us. But this kind of stuff does show up on the ACT a good bit, where it's called a weighted average. And so you can memorize the formula here, but I want to show you where that formula comes from. So a weighted average takes
Huh?
sample 1, or the sample size of 1, times its average, plus the second sample size, times its average, and then divides by this. And tell you what, that's a formula to memorize, isn't it?
Or you can just think about
It's
it.
chemistry. Or we're not chemistry, but.
So, remember though, what is a mean? What does it mean?
I just need like an example.
So get back there?
Yeah, exactly. I just don't like it.
It's the sum of all the values divided by n. And so, if I take this equation and multiply it by n, aren't I just finding the sum of all my values?
Yes.
So this is the sum of all the values from the first set of data. This is the sum of all the values from the second set of data. And then, so I have all of my sum there, and I just divide by how many total data points I have. Now, I do want to point this out. I will never use that formula. You know why?
Because you
Yeah.
just think about it.
Because it's easier to just say, hey, 8.2 is equal to the sum of all of my x divided by 200. Okay, that's a sum of, what was it, 1640?
Something.
Yes.
Multiply both sides of the equation by 200.
1640, yes.
And then the 2.5 is the sum of all my x divided by, was it 18 again?
Yeah.
Yes.
So the sum of that x is
45.
45. Cool, so my total, and you can use different notations if you want. You can put 200 here and 18 here to make it clear that it's the 200 and the 18 teachers. But the total mean is going to be,
Do
that's
you have
it.
to show work on the AP exam?
Yes!
Oh.
Man, how am I supposed to show work for that?
You write it out
Like,
like
how
that.
many bio?
Yeah.
Or if you memorize this formula, you can use that formula as well.
We don't actually count. We are doing this. This is what I can do.
Stop shaking my
You
desk.
don't have to.
I use it
But-
for everything.
Yeah, I will say this, I would start practice writing symbols like the subscript to 200, subscript to 18, or something like that, because it's gonna help you a lot when we get into inferential statistics. So practicing it here when you don't need it will help you be set up well later,
I mean, I boxed the answer.
okay? Say again?
I boxed the answer.
Perfect,
I did too.
that's great. Okay, so whatever that is, what do you have to be, 7.73 or so?
Yes.
Yeah.
Okay, I'll show you what the rubric says in a second, but the last piece I want to look at is it high school B where they're asking
Mhm.
within 1 standard deviation?
Yeah.
The reason why I picked this problem is we're about to go into normal distributions, okay? In normal distributions, you don't have to do what we're about to do here, but this is still the foundation for everything that we're going to study with a normal distribution. So, 8.2 is somewhere in here. We said it's within how much? 7.2 is the standard deviation.
Yeah.
So all the way from 1 all the way up to 15.4. Okay? And it just asks, hey, what's the probability that's within those teaching years, right? I know a lot of us got a little freaked out here, but how many teachers were there in high school B?
A few.
221, right? And if I want a probability, was it a probability?
Yeah.
Yes.
So next unit's where we're going to hit more heavily probability. So this is actually a question 5 off the AP exam. Question 5s are typically mixed bags, meaning they have multiple concepts at play. Notice this is why they didn't ask about cusp, because we had the idea of median, we had the idea of mean, and now we have a little bit of probability mixed in there. But I just need to know how many satisfy that requirement. Remember, when we say probability, the classical definition of probability is the outcomes of success divided by total outcomes. What we'll actually talk about is the frequency of success today, or next unit, divided by the total. So, and straight, I was actually thinking about this a little bit later. It might actually be easier to just count these up, but all you have to do is identify how many are in each of these. How many were from 1 to 4 year? 79 plus 4 to 7 is how much? 34? Plus, what's that, 27, 28, somewhere in there? And 10 to 13, 24.
So do they have like a range of like values?
Let's go find out.
Why can't you just say yes or no?
You know, Michael, it's like you never had me as a teacher before.
I know.
Wait,
right?
wait.
So what does this come out to be?
I thought it was 29.
85
Or like
points.
the second one. It's like, it's not.
Which one? This
Or
one?
10, 13. 10 to 13.
Oh, maybe I was looking at the wrong
Oh.
bar. I was thinking it's down here. You're right, it's 29. I went across and wasn't paying attention. I thought it was 25. All right, so 29 plus 19, etc. So what do we get for our probability?
188 over
Great decimal.
0.8507.
Typically, when we do probabilities, we will end up with decimals. But those fractions would have been defined as well. Did I put the scoring rubric in here? I did not. I'm gonna say scrub move. Good thing I pulled it up here. Okay. Alright, so did we state the median is 6 for high school B and 7 for high school A? Yeah. Did we provide a reasonable explanation of how the decision was made? And did we provide the definition of the median or explicitly apply the definition of a median as a criterion? Yes.
No.
Define
Why do we have to define it?
That's what it says.
No,
Notice it says-
the median.
It explicitly applies the definition of a median.
Oh.
So you remember how we looked at 110, 1 and 110?
Mhm.
Yes, Mr. Kenny? Okay, right, so when we did that, that was applying the definition of median, even if we didn't actually define
Oh,
it.
it talks about skewed on it.
Here's another option, right here. So would it have been acceptable to talk about it being a skewed distribution, so it would have a lower median?
Oh, I didn't talk about it.
I think that's what it's saying. So median is 6 for high school B, median is 7 for high school A. High school B shows a skewed distribution and A is less skewed. And so you do have to talk about an explanation of how the more skewed distribution would be the one with a larger separation between the mean and median. So you probably got a P on that.
Yeah.
So, but notice that, was it possible to talk about that skewness? You just need to make sure you take it to its full reasoning of like, because B is more skewed, the mean is gonna be further from the median, so the median is probably the 6. Does that make sense? Like the more skewed the distribution is, the further the mean and median are apart. That's kind of what they're saying there. Questions?
Wait, what's that? Wait. Oh, wait, never mind.
The further the mean and median are apart, or the more skewed, the further the mean and median are apart.
But
See,
it's
Mr.
talking
Charles?
about median now.
Say again?
I thought it was talking about the median.
Oh, but they gave us what the mean was, didn't they?
But what does that have to do with the median?
Well, because what was the mean for both of the
Oh,
distributions?
8.2.
So if the median, or the mean was 8.2 for both distributions,
Oh, it does say.
and B is more skewed, right?
Um,
Then the mean and median have to be further apart. So the median would be 6 for B and it would be 7 for A because the mean and median are not as far apart.
I just looked at it with my eye.
You need a little bit more justification than just looking at it by your eye.
But isn't the point
But
of
it's
graphs,
obvious.
isn't the point of graphs is to show the data so you can.
Right, but you gotta have clear evidence for the claims you're making in statistics. Alright, part B. Correct answer to the mean is 7.3. Do we have to have some kind of work?
No.
Notice that the language is just enough work to show that the answer was obtained as a weighted average of the two individual means. Meaning you found the sum of each two, and that was it. So you could have, I think they use the actual formula up here. See how they use that actual formula?
Unnecessary.
Well, but I mean, it's quick. If you know this formula, it's really quick. But if you had just done these two separate pieces and shown work to get there, you're good. You don't have to do it exactly the way they said it. That's why that's an idealized answer, but they have this rubric here that says, hey, as long as you have work to show that you accounted for the fact that there was 200, because when they say weighted average like this, some students are going to be very tempted to take 8.2, add it to 2.5, and then divide by 2. And that makes sense, right? Because that's what averaging is. But when you have 200 teachers that have an average of 8.2, that's a lot more than just 8.2. Okay, so you have to do a weighted average there. And so that's accounting for that. Questions about B? So I know we already did it, but. Alright, finally C. Notice you have to have the appropriate interval of 1 to 15 years of teaching. Sums the counts of data values in the numerator based on the intervals provided, and divides by 221. Notice, if you just got that probability without supporting work, what'd you get? A P? Even if you didn't get the correct answer, but you got 2 of those components, so maybe you just showed that you got that interval, and you show that you got the denominator, it's a P, right?
Is there a
So,
range?
say again.
Is there a range?
I will point out, there's actually not even,
Yeah, it
it's
doesn't.
not a part of the E at all.
What the crap?
Wait, so if you got that, you wouldn't get
Oh,
it.
okay, so it's just like, it doesn't matter what.
Notice it says, I don't love the language there, but essentially what I'll say is this. If it's close, here we go. It is acceptable if the count is slightly off because of difficulty reading the exact heights of the bar in the histogram.
Maybe we shouldn't make it difficult.
I know, but
But,
that's kind of nice that they're flexible. Like, that's what they're saying. Like, that means you could be off by multiple counts as long as it's reasonable, but it may just be like, oh, they didn't
How's it
see
gonna
this
be?
graph right, then you're good.
So it's giving ACT.
Say again?
It's giving ACT. Sometimes.
you know what,
No, the ACT sucks. What?
No, I was gonna ask, but getting the 85 would still be only partially correct, so.
If you just wrote this
Oh, okay.
without supporting work,
Oh, gotcha.
Okay, so I still have a chance of getting everything.
Oh, okay, so you just have to, but with the word and the 85%, it would count as essential.
Right.
Gotcha.
as long as you get these three things. Right, you have to have those three components.
Oh,
Okay. Yeah.
How do you, 15 at the end?
So remember how we were looking at earlier that the mean was 8.2, right? The standard deviation, which by the way, I think it was Jaden, you wrote X bar here, but this was all the teachers at the school, wasn't it? In the problem?
Yeah. Yeah.
So I don't want to use X bar, what do I want to use?
Ah.
Remember, that's the population mean, mu,
Mute.
my population mean. So if I got population, I'm using that. And then the standard deviation was 7.2. So it said within one standard deviation. So what's one standard deviation below 8.2? Just subtract it by 7.2, right? What's one standard deviation above 8.2? So it's one standard deviation each way. We're gonna play with more with this in a second. Whew, was the last 25 minutes we have of class.
What?
I know.
Oh my god.
I know. Alright, so here's what we're about to do. So we're gonna have to pick it up tomorrow. Now, beware, tomorrow we are going to do a demonstrate understanding on quantitative data.
Hello?
Oh,
Yo, I told y'all about this last Thursday or Friday. There was a shot of it being today. Yes.
me not
Hey, man.
remember.
Thank you.
Yeah.
Thank you.
I remember.
y'all.
Gaslighting.
I told y'all on Thursday,
Gaslighting.
but I didn't want to put it on y'all today because.
Oh, now I
Oh,
remember,
it's
kids were
Monday.
complaining, like, don't make it Monday, don't make it Monday, I remember.
Yeah, thank you. Mm-hmm.
Well, you should have told us Friday too.
Yeah.
Told.
I'm hurt.
Told, whatever, proper English.
You know
So, here's the thing though, guys, legitimately, we're gonna have to do the normal distributions, demonstrate understanding either Wednesday or Thursday at the absolute latest. So we need to do the quantitative tomorrow.
Wednesday. I hope that's Thursday.
Yeah, we should
So,
do both.
what we're about to look at is density curves. Normal curves or distributions, the empirical rule. We're going to use the empirical rule to estimate the percent of observations that are within 1 and 3 standard deviations.
Wait, so is this front and back of the yellow sheet, or just like the next
Still the
yellow,
same
the fair
sheet.
model?
This is the other. Actually, this is the new fair model that I had Miss Kowalski make copies of.
What the crap?
So this new fair model, what we're doing right now, this will not be on the demonstrate
Wait, so
understanding.
what about the other one?
So which
The-
one's,
The second sheet, this one that says quantitative data on both sides.
yeah, mine's looking.
Mine is
Okay.
unfulfilled.
Yeah, I thought I didn't have that in your homework tonight, but no.
What am I supposed to write for this?
It's just back.
Just
back,
any
back.
notes you need for how to get those summaries. So,
Okay, both sides?
like the listen spreadsheets, things like that.
Didn't we already have this?
For quantitative, yes. What?
Didn't we already have this?
Not the percentiles and z-scores. Not yet.
Okay.
As much as they're whining right now, unless we get there, I don't wanna.
That's not what?
What?
What? Nothing.
I'm prepared. What can I
So wait,
say?
which,
Why do we have 3 of these?
I'm sorry.
I
Where'd
just
it
have
go?
so
Oh,
much
here it is.
I didn't do any of it.
What the heck is this?
Isn't it Z-score just negative 1 to 1?
Yo, guys,
this is
listen.
what we're doing?
I haven't, no. That's what we're about to do.
Negative 1 to 1.
But that's not what we was on the demonstrated understanding. Guys, the demonstrated understanding is only on the quantitative data stuff. So histograms and dot plots and mean and standard deviation and box plots and IQR and all that kind of stuff. That's what tomorrow's on.
This is due tomorrow.
Correct. So, alright, we did our 3 activities really quickly.
Push me.
Rolling a die and recording the value it lands on. Which of these histograms is it?
Stop, I'm trying to.
So this is activity 1 right here.
Stop.
The shape, what shape is this? Uniform. Is the mean greater than, equal to, or less than the mean?
Equal.
Equal. Okay, which activity was this one?
2.
Tossing a penny. Shape.
Skewed right.
And?
Can you stop shaking my desk? Jamie?
Alright, is the mean greater than, less than, or equal to the median?
Greater than.
Greater than? Why do we know it's greater than there?
Because it's an outlier, so it's going
Skewed, so it's being pulled towards the
tail.
skewness to the tail. Alright, what are we gonna call this thing?
Unimodal symmetrical.
Unimodal and symmetrical. Yeah, true, that is true. It's unimodal and roughly or approximately symmetric. Just as a preview, anybody know what we're gonna call this histogram right here?
Normal distribution?
That's gonna be called a normal distribution. So what's one thing right away that we should hopefully note about that normal distribution that's gotta be true?
It's pretty
The
like
mean and the
even
median
both sides.
It's roughly symmetric, it's what?
Pretty even on both sides.
Pretty even on
There's no
symmetric.
skewness.
So it's symmetric, right? No skewness, what else?
The mean and the median are equal.
Mean and median are equal, but, I mean, that's true over here too, right? So what's gonna make something normal?
Returns back to 0 on both sides.
Is it the, whatchamacallit?
So let me ask you this, would that be approximately normal?
No.
No.
It's bimodal.
That's bimodal, so the answer is,
No.
so what does a normal distribution have to be?
Unimodal.
Unimodal and roughly symmetric. There is another key to it though. And we're gonna talk more about this. So for example, let me start here. Do you think that would be approximately normal?
No.
It seems too steep.
That's a pyramid.
It could.
No, it is.
It's the same amount of stuff on both sides.
So it is the same amount of stuff on both sides, right? But I mean, does that look like this shape?
There's
No,
no
it's
curve.
The standard deviation.
Do you remember a shape that we talked about last year?
No.
That it could what?
Bell
A
curve.
bell curve. Remember we talked about it being bell shaped? So when we talk about a normal distribution, one, yes, it needs to be roughly symmetric. It needs to be unimodal. But that is not all that defines it. The other part is, just glancing at it, it needs to be bell-shaped. There's actually one more key to knowing if it's approximately normal or not, okay? So, roughly symmetric, unimodal, bell-shaped, but there's one more thing that we need to check. Yeah?
Could you technically draw that one in a triangle shape though?
You can draw anything
The
in
middle
a triangle
one,
shape.
Yeah.
Activity, could you technically do that?
You could, but we're generally gonna make this, so let me say this. We will talk about the other part that makes this normal in a second, okay? So one thing I do wanna point out is, notice with true histograms how we have bars like this. There was a vocabulary term I used a second ago. I want you, if you have your proficiency scale out, I want you to go back and I want you to look at your proficiency scale, or I'll even put it up here. What are we gonna call it when we smooth out that histogram? It's called a density curve. So, is this curve right here exactly what this graph looks like?
No.
Is this graph right here exactly what it looks like? No. But that smoothed out density curve is really useful in statistics because one, that density curve smooths things out, right? So density curves smooth the graph out. It's hard sometimes to know probabilities and area when you're looking at a true graph like that. But a density curve is going to smooth the graph out. And here's the next piece that's really, 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 really important. The area under the curve is always, anyone know? Have a guess? Well, you're getting something you're remembering from last year. Hold off on that for now, though. Let's see, I have the whole thing. What's the percent? 100%. So what would the area be? What would be the decimal that corresponds to 100%? 1. So the area under a density curve is always 1. So because I can find that area easily, then I can find that percentage easily. So a beautiful part about density curves is that the area under the curve is always 1. I am going to go back and look in the textbook tonight to make sure I'm not missing anything with that, but I do want us to get to the next piece of this, okay? So, what I want us to do, one group, or one person per group, pull out an iPad, and I need you to search for this applet, okay? And I'll explain more when we get there in a second. Yes, Serena?
I go to the bathroom.
Run like a wind bullseye. Okay?
2 bed, 2 sets.
She don't guess her.
As soon as you lose losers.
Okay. Jaden, can they borrow your iPad and y'all look on with Serena's?
Oh, yeah.
I mean, I would want to bring that for bio anyway.
Okay.
What?
Bro, I think you went today.
I know we're looking at Apple, I'm like, which one?
And if you went today, we were all.
The one that's on the board that you just actually took off the board.
It's also on the sheet
Did he buy it?
Yeah.
No, if he.
where it says down here in the bottom, search for BFW Publishers applets. Go to updated statistical applets. And then find the normal.
Does he
density
not
curve
like
applet.
they talk about Asians doing?
Oh, we have
Does he
so much diversity in here.
No, he said that. No. When I was in the bio 103 class with Amy.
Alright, Michael, are y'all already ready?
Yes.
I'm searching.
Okay, I got you.
It's over there.
Yes.
Y'all need
Stretch your
Because
legs.
when we're
Okay,
whenever.
this is what you should see.
Asians being racist, he always be like, yeah, Asians fight my goal. I was like,
Huh? Yes, the directions to get there. Okay?
Very interesting.
I say it.
Okay, so I want y'all looking at this. Now, one thing I need you to do, I will point this out, is first off, this is a density curve. So what is the area underneath that density curve going to be? 1. What type of distribution is this density curve?
Sorry.
Say again. It's normal. How do we know it's normal? It is symmetrical, unimodal, and bell shapes, right? So that's a key. Now there's, again, this final piece that I want us to do. And so here's what I need you to do. Things are going to be a little bit different per group. Lana and all of y'all, I want y'all to have a mean of 5.1. And what was the standard deviation? Was it 0.1? And a standard deviation of 0.1. This was some data that was collected by the mathematic people when they did this with their students last year. And so their average stopwatch time was 5.1 seconds with a standard deviation of 0.1 seconds. And what I want you all to do is I want you to find what area within 1, 2, 3 standard deviations with that mean and that standard deviation, okay? Okay, so Ms. Kowalski will be there to help y'all. Jaden, Sprigg, I want y'all to do it with IQ scores. So the standard IQ score is, or mean is 100, standard deviation is 15. And again, I want you to find the area within 1, 2, and 3 standard deviations. And y'all are gonna do it
First of all, is
with the
this
0, with a mean of 0 standard deviation. Okay?
Technically,
Where this is at is this within,
but like the mean's lower.
within 1 standard deviation. The
Make
numbers
things
it's
easy
giving
for
you.
us, Jaden. Hey, really quickly for everybody. Hey, right here, I do need y'all to see, drag your bars
I wasn't
so they
gonna tell
pass
you
each other,
that.
because what we want is the area between, right? So you want the area from 1 standard deviation below to 1 standard deviation above.
Here's a stand.
You're an old woman. God.
Why are you like?
Alright, then.
I was like,
Yeah.
yeah, right?
Okay,
Y'all.
so
Not bad.
what I will point out is this is the mean of 100, which yes, it's a little bit lower because Americans are dumb. But the mean of 100 and the standard deviation of 15.
Go away.
There we go. I got it.
Mean of
Whoa,
100,
that was
standard
crazy.
deviation of 15.
Okay.
That's IQ
Okay,
score.
computer science.
So the
So you grab it.
percentage of people that score
Well, now
from
it doesn't
85
work,
to
right?
115, one below to one above, is roughly what percent? 68%.
You do it.
You just tried it, but it wasn't working for me. I might have to do
I don't know. It's
Oh.
acting like
Pretty
it's
decent.
low.
Because I haven't looked at my
Yeah,
IQ
but
score
it-
since I was in like 3rd or 4th grade, and I tested into a gifted program.
it. So put it in with 1.
Let's find out. Okay.
So that number one.
Yeah.
So within one
Well-
standard deviation,
That would
It's
be one
68%.
standard deviation because it's
Oh.
one above.
Oh, yeah,
and
it is, yeah,
one
the
below.
standard. Oh, okay.
let's find out.
Wait, what?
Within two standard deviations.
So this is within one standard
25%.
deviation, right? Because this is what our curve looks like.
Okay, so
Oh my.
we're gonna talk about that later, but, so we're talking about within
No.
one, so one, from one below
What
to
was
one
that?
Well, I-
above is,
No, maybe you're just,
Yeah.
maybe you have to teach like every single subject.
No.
I like
that's
seeing
okay.
those, but it's
I'm
like
a
someone
math
just keeps on
person.
doing
So what's your mean
the
from
death
one
drops
to
and
two
again and
below,
again.
two above is,
5.2,
and do three below and three above.
5.3,
I'll try.
City of Pennies.
5.4.
Yeah.
Then go
I used to
down.
let me grab my pen.
Run like one bullseye.
I was gonna ask that.
Well,
What is that phrase he's saying?
I don't know, he just wants to be.
Oh, we
Y'all.
talked about this before.
Y'all. Toy Story.
Oh, yeah, I remember.
Oh, yeah, I
Yeah,
forgot.
I
What is Toy Story?
Attention.
Attention. Let's look at
Yes,
this.
ma'am.
This is what we just saw.
Yeah.
Right? This is within how many standard deviations?
Oh, zero.
It's within one.
It's funny when I
This
do
is
it.
our mean. One standard deviation above, one below. Two
Can't read,
below,
hold on,
two
sorry.
above.
Yeah.
Three
Hold
below.
on.
So what was this proportion under there? What word are you using? The area. What is the area within?
0.6778.
So you got 0.6778 for one standard deviation.
Do we round?
Now you do that for two standard deviations, so try to drag it.
Oh my god, I got it.
Yay.
First try.
What'd you get for
Alright.
two?
Wait, 0.9534.
So,
And then do three.
let's look at them. If you, so y'all were the ones that had the stopwatch times, correct? So when you look at the stopwatch times and a mean of 5.1, standard deviation of 0.1, what percent of the data was between 5 and 5.2 seconds?
I just did that.
6.6778.
0.6778, what would that round to?
Round to what?
Round to
Let's go 2 decimal places.
68.
0.68, or so what percent would that be?
68%.
68%, right? Okay, so IQ, yeah, IQ, nope, yeah, IQ, intelligence quotient, I keep trying to say IQR. Your
That's what I
IQ
thought you
score,
were
there we go,
Okay.
has a mean of 100, standard deviation of 15. What percent had between an 85 and 115 for the IQ score?
68.
68%. And when y'all just straight did a mean of 0 and a standard deviation of 1, what was from -1 to 1?
0.683.
So 0.663 or 68%. For stopwatches, 4.9 to 5.3, you got 95%. IQ scores,
Oh,
70 to 130.
98.
95?
95? Was it 98 or 95?
98.
Was it 98?
Girl,
Oh, it is 90.
just because I found that little graph.
99?
Wait, are you on the 70 to 130?
No.
Oh, that
What
was,
to do?
Jaden.
One, yeah, one.
One
that
job.
was 80 something.
No.
95.
There we
Oh,
go.
95%, okay. And then what was it from -2 to 2?
No!
95.
We already said that.
I understand it now.
And then, so 4.8 to 5.4 seconds. So 3 standard deviations below to 3 above was what? 99.7. 55 to 145, or 3 standard deviations below to 3 above was? And?
9.7.
So, this is called the what?
Empirical.
Empirical rule. So the empirical rule is something that all normal distributions follow. So if you have a curve that is unimodal, that is symmetrical, and maybe it kind of looks bell-shaped, but it doesn't follow this rule, for example, that one with these really heavy tails, that wouldn't follow the empirical rule. It's bell-shaped, but that's not going to follow the empirical rule. So, at least I don't think it will. We can check. But I don't think it will. But regardless, like if it doesn't follow the empirical rule, is it truly normal?
No.
No. All normal distributions, which by the way, I do want to pause and point this out, are any distributions truly normal?
No.
We would, in statistics, say they are roughly or approximately normal, okay? In statistics, we always say approximately or roughly normal. But if a distribution is approximately normal, it's going to follow the empirical rule that says what?
What's below, what above is 68.
So 68% of data is within one standard deviation, so within from one below to one above. 95% of the data is two below to two above, and 99.7% of data is from 3 below to 3 above.
Where's this? I can see it.
Okay?
Why are you kicking me because you can't see it?
I'm trying to look at my feet.
How do you have?
Yes, if it's real world data. Now, in AP statistics, we are going to assume that it is those numbers if we're told it's approximately normal. If we're told it's approximately normal, we're going to use the empirical rule. Now, it is important to note, what percent of the data is underneath the entire curve? 100%. So, just looking from 3 below to 3 above does not mean you're looking at the whole graph. Keep that in mind. That's something that has caught my Algebra 2 students off at times because they forget about the 0.15% on either tail to get up to the 100%. But we're going to apply this empirical rule in just a couple minutes. There's something I was going to say.
Wait,
though.
empirical rule is standard deviation, right? Like-
Well, so the empirical rule connects the standard deviations in a normal distribution to these percentages. 68, 95, 99.7, that's the empirical rule.
How much did I miss in like the minute I was gone?
All of it.
Yeah.
But, Serena, you did this, right? Wasn't 68% of the data from 85 to 115? From 1 standard deviation below to 1 standard deviation above?
Graphic
You can see it right here.
Right.
Okay?
Hey,
2
stop
below
showing
to
us
2 above is 95%. 3 below to 3 above was 99.7%. Okay? And so this is just one of those things that is. Now we're going to skip number 2 on that side. We're going to go to the back side. I'm going to show you how this kind of plays out with the check your understanding. We're going to get practice with this tomorrow. I did have Miss Kowalski print some stuff off from Skew the Script for the practice. I felt like Skew the Script was better for practice. But right here, so here's how we use this. First off, go ahead and start practicing your normal distribution drawings. You will need to draw a normal curve on the AP exam several times. For sure, okay? So practice it. It's just like an infinity symbol. I don't know if it took you a while, but it took me a while to get comfy with drawing an infinity symbol. It's taken me a while to do a normal curve.
And then just an 8.
Like, it's just.
It's a little different, but
What do you
it's
mean?
fine.
It's just like,
I just flipped my paper.
hello?
listen.
Just something simple.
Sorry, it was a bad example. But coming back to this, normal distributions do take a little bit more time. I'm going to show you a detail to help you draw your normal distribution well. And this is something that I did not learn until more recently. But when you draw a normal distribution, so here's my normal distribution. To make sure, or to check that it's approximately correct, I'm going to go to, so right here is the what? What's right in the center? The mean, right? Okay, so in this case, the distribution of waist circumference for women who are 8 months pregnant is approximately normal with a mean of 44 inches and a standard deviation of what? 4 inches. And now I know the 68, the 95, and the 99.7, but I need to actually still draw those standard deviations in here. I'm going to go roughly to about right here. And this is not random. There's a reason why I went to this point. Nate or Lana, do you remember what that point is?
What's it called? Here. You said intersection.
What is?
You said
My
the
intersection.
version is You're on the very cheeks. Okay, 44-inch waist.
Inflection.
No, I'm at like the
So look, guys,
beginning.
this is the point of inflection, right here,
What ways?
and right here.
Excuse this interruption. Correction to an announcement this morning. There is a Diamond Girls
You
meeting
see how that's concave
this
down right here?
afternoon in
So that curve is
room
concave
401.
down, it's going down.
Again, the Diamond
After
Girls
this point,
meeting is this afternoon in room
curving
401.
up to be concave up. That point of inflection, where the concavity changes, is where one standard deviation is. So, this is 48. I'm going to take that distance and I'm going to repeat it. And notice, now I'm really close to the end. And roughly how many standard deviations are on either side? 3, right? So that point of inflection, and then you repeat it to get your other standard deviations or distances. So you do it on both sides. Now, go ahead and start getting used to this as well. Frick, I didn't realize what time it was. Hold on one second.
I gotta go.
Right here, hey guys, the mean. How many standard deviations is that mean from itself? What was the numbers y'all had? What was right in the middle? I think didn't y'all have a 0?
Dude, I gotta go.
When y'all did it on the.
Why do you always make the class so late? Like, whatever.
Dude, I didn't put on my leg.
Because, like, I need to be there by 3:15.
1, 2,
I gotta
3,
fix my
next
legs.
one. Guys, I'm just trying to point out, it's 1, 2, 3 standard deviations above the mean, 1, 2, 3 and below the mean. Pay attention to that point of inflection. We're gonna use that tomorrow after the demonstrate your understanding.
Oh my gosh, they did it. Did you do the attendance?
Yeah,
I don't think I did attendance, they just gave up.
They just gave up.
Dude, I would get up there.
They're like, he'll do it eventually.
I'm being hard countered. Or I have a soft counter and hard counter.
Yep, no, definitely did do it.
Explain and momento.
My soft counter is the school walls. Look at this packet there.
I guess it's gonna be DY, yeah.
15, 8. I'm supposed to have around 200. At Chick-fil-A, at home, I have around 200. It's called these walls.
I'll work on a solution set to about 2 years.
I can't pay out there.
Yeah, go for it. So this is where we should be talking about custom content. This is so that you can give more information about the different types of shape. Like if you would run out of room right here. No, but like, so like if I were you, I would at least talk a little bit more about what these things mean. And if you can fit the ideas about shape down here, then cool. You don't have to fill all this. You just need to be complete with your information. So look in the book again. So for example, I have a copy of the book here.
Why are those books coming?
Right? I just wish I hadn't about them last week too. So we're on what? Unit or chapter 1. So,
So,
yeah,
One thing
because
I would note,
the box plot stuff over
like, it's
here.
not that big of a deal, but I would keep it closer just because it's not, the end should meet here, if that makes sense.
Oh, so I can just write pretty confident or stuff. I can just use
No,
those.
so more.
Yeah,
I
but they
can't
only
write
have
on
the
chalk.
TIE
I can't
4s,
do
they don't
chalk
have
on my
TI
hands.
Spires.
I'm not very good at
Look at the
drawing it,
time.
Right? That's what I'm
but
saying. I was super
your
disappointed when
end
they're like,
should
ooh,
meet-
we do everything with the 84s
I'll
on
make
that.
it close, yeah.
Um,
0.
So here's some information about comparing distributions, describing.
I keep
With
doing
that
that.
type of texting.
Because I don't have it in person.
It's digital, it's all.
But,
I know,
do
I'm
you want
trying to
yours
get you
to
all.
touch?
So just here, stuff like
Because
that.
if there's a
Anything
gap,
else you can think to add in?
like that's not, like it should be enclosed. Oh, that makes sense.
But I would just draw
I
the city
just like
curves.
keep that one
That's equal.
when you're drawing.
Yeah.
Right.
Like I wouldn't do, so like that's a density curve.
Oh,
I wouldn't do that.
okay.
I wouldn't do histograms, I wouldn't
It's
do
not
dot plots,
the
I
end
just
of the
do,
world, I promise it's not the end of
density
the world,
curves.
I just try to be more aware when I do it.
Right, it just helps you.
Now,
Yeah.
granted, I think you also are already addressing some of the things I would have planned to talk about right here with like how the mean and median are related, stuff like that.
So like that's what I'm saying, like I kind of, like these things kind of have overlap already.
Yeah, and that's fine, as long as they're somewhere. Now, here, one thing to keep in mind with statistical
Oh.
parameter, well, just what's the symbol for, that's the statistical mean, what's the parameter mean? And then, remember with statistical parameter for standard deviation, they're actually a little bit different.
I was like the capital.
That, but also, do you remember?
Oh, it doesn't have the n minus one.
Correct, it just has the n. So, there's the standard deviation, right?
That looks good.
And then they give an example or explain it. Well, they don't explain it in here. They do just use the n though if it's not as simple. Huh. Surprised they don't give that just n to the population one. But yeah, that's it. Yeah, just use your textbooks to your advantage. Part of the reason, so like, we even made a decision not to give out the notes that go with the guy who wrote this textbook, because if you just use this, you'll get the same information. And we're just gonna use mathematics to use script. Dude, you're like 3/4 of the way there. You really don't have too much to do, I promise.
I mean,
And it'll help you study for the demonstrate your understanding.
whatever. How many questions are there?
Great question. Do you remember? Yeah, neither.
It was front, back, front.
I don't even think I put any false questions on there. I think it's majority like 2 page, like front and back of multiple choice, and then one of
Well,
maybe a multiple choice in some free response.